Hi class, so this week we're covering Chapter 8, Sampling. So the objectives for this week is to describe the difference between a sample and a population, explain the rationale for choosing to study either an entire population or just a sample, identify the two main approaches to sampling and explain their key differences, list and discuss 4 different types of probability sampling, and to discuss the concept of sampling error and identify strategies to minimize those errors. So when we say population, what do we mean by that? So a population is the totality of persons, events, organizational units, and so on that the research problem is focused on. The sample is a subset of that population. So as one example, if the researcher conducted a study of students at your school, so let's say the researcher was conducting a study at A&M Commerce, the population would consist of the entire student body. Any subset of that population, for example, if the researcher just selected 100 students at random, then this would be considered a sample. So many times when sampling is the preferred approach, researchers must then decide to select the elements they wish to study. So when we talk about elements, this refers to each member or entity in that population. Another question that the sampling plan must also consider is how big should the sample be? And then whether or not they plan to indicate whether this will permit for inference. So by making an inference, the social worker is basically saying that what holds true for the sample is also true for the population from which they are drawing that sample. So when thinking about whether your sample is any good, there's 2 things to think about: representativeness and inference. So I just kind of talked about inference a little bit. So basically, the researcher is claiming that what holds true for the sample is also true for that population. In terms of inference, you have to have a representative sample. And a representative sample is basically how well does the sample represent the population. So whenever you draw a sample from your population, in order for you to be able to generalize that, you would have to make sure that your sample is representative of the population. So here are the steps in creating a sampling plan. There's 6 different steps: defining that population, deciding whether you're going to study the entire population or if you're just going to draw a sample. Step 3 is to construct or gain access to a quality sampling frame. 4 is to decide between probability and non-probability sampling. Step 5 is to select your sampling method. And then step 6 is to determine that sample size. So we're going to cover each one of these individually. So the first step is to define your population. So the first step in developing your sampling plan is to develop the clarity on the population that you're going to study. And this might sound very straightforward or very simple, but in reality, it can be difficult to decide who's in your population. For example, you're trying to define family. How do you define family? Family can have so many different definitions, right? It can be simply parents and their dependent children. What about adult children still living at home? What about if you have extended family members living in the same household? So how do you go about defining your family? And that will depend on the researcher and how they define family. Same thing with adult children. How do you include adult children? Who's considered an adult? Are you going to consider those who are 18, 19, or 21 an adult? Also, what about grandparents, if they're living in that home or not? Suppose, for example, that you have a population of elderly Chinese people. So how would you describe or how would you define that population? Would you restrict your study to only American-born Chinese people? Would you also include elderly immigrants from China? What about immigrants from Taiwan or Hong Kong? So the researcher has to decide their boundaries for that population. And whoever is included, it needs to be clearly stated as to who's included under the definition of elderly Chinese people. So there will be times in research when the population elements may not be exactly the same as their sampling units. So the sampling units are the entities from which the data are gathered. So for example, a social work researcher may be interested in a population whose elements are preschool children. But the sampling units may be the parents of those preschool children because they're the ones who will respond to the researcher's request for information. So the first step in developing your sampling plan is to make sure you specifically define your population in terms of the elements as well as the sampling units. So why should we sample? Feasibility is very important, right? So if you have a large population, it may be very difficult to research or to study the entire population. So therefore you'd have to just draw a sample of that population. So it's easier, it's faster, it's less expensive than actually studying the entire population. It may also be more accurate. So you may not be able to find all of the members of the population if you're trying to study the entire population, especially if it's a very large population. So if it's feasible and the population is less than 100, then you should study the entire population. All right, so next step is to develop a sampling frame. The sampling frame is a list of all the elements in a population from which a sample is selected. So together, the totality of the population elements on the sampling frame is referred to as what we call the sampling universe. So when it comes to the sampling frame, this can be, for example, at an agency, their client list. It can be telephone directories. You can look at NASW members, the list of the members. The closer the sampling frame approximates the actual population, the less error you'll have in that study. So the researcher's goal is to try to get a sampling frame that is comprehensive and free from error. So for example, when the population is school children in a district, the sampling frame may be a list of students obtained from the registrar's office in each school. Okay, so you may have some sampling problems. You can run into some sampling problems. So we talked about how the sampling frame should be comprehensive and error-free. Like, for example, a list of youth at a summer camp or a list of students in a school district. However, if you're missing students because they're either new to that school district or the list may not be updated yet, then you may run into some what we call sampling bias. So when it comes to sampling bias, it is a problem with the selection of elements that produce systematic errors in the research study. So for example, if all students with low test scores were left off of the sampling frame, then the study would have sampling bias. If there's sampling bias, then you cannot generalize your results. Other examples would be if you only include English-speaking children in a study. And another example would be if you only include those who did return forms back. For example, let's say you sent out forms to the entire school. However, you only include those who returned those forms. Those who were not included may be different than those who returned those forms, right? So those who did not return their forms may be completely different from those who did return those forms. And so we cannot therefore generalize our information. We cannot therefore generalize our data that way. Students with low test scores not included in the sampling frame. Again, another example that those who had higher test scores may be different than those with lower test scores. And so you cannot generalize that data if you don't include both students with low test scores and students with high test scores. Other problems can come from having incomplete sampling frames. So for example, if you have new clients at your agency and they're not yet entered into your database, then your sampling frame would be incomplete because you don't have everyone from the population. And so when you draw your sample, you're not drawing from the entire population. People who have moved can't be found. Same thing. Those who may have moved, you aren't able to find them, and so they're not able to be a part of the sample or even have a chance to be selected. And then we have non-sampling error. So with non-sampling error, it is not related to the actual sampling procedure, and it includes inadequate sampling frames. It can be high levels of attrition or non-response, and measurement and data entry errors. So that's what's included in non-sampling errors. So you have to be careful when you're entering data, making sure that you're not mislabeling anything. Attrition, you can't really control that. You can try to address it by trying to do some things to reduce attrition. Non-response, kind of the same thing. It's hard to be able to reach those who are not responding back to your survey. So the next step is to select the sampling approach. So we have probability sampling and we have non-probability sampling. So we're going to start off with probability sampling. Probability sampling is a procedure where each element in the sampling universe has a known chance of being selected. So all probability sampling approaches involve random sampling. So we talked about random sampling when we discussed chapter 7. And remember, with random sampling, each person has an equal chance of being selected. So this is similar, for example, to flipping a coin or rolling a dice. Chance alone determines which elements gets into the random sample and who will not. So there is no purposive inclusion or exclusion of any element. If the researcher randomly selects enough elements, then the sample should represent the population. So when it comes to probability sampling, the major advantage of this approach is that it permits generalization. So because each person had an equal chance of being selected, they were randomly selected, and so the sample should be representative of the population, and therefore you can generalize those results. So probability sampling is generally used for descriptive and explanatory research. Non-probability sampling, on the other hand, is used for exploratory research. So with non-probability sampling, this is the procedure in which all of the elements in the population have an unknown and usually different chance of being included in the sample. So non-probability sampling does not support the claim that sample is representative, and therefore it cannot permit generalization, only speculation. With non-probability sampling, this approach is inexpensive, it's convenient, it's very easy to do. You can definitely do it with your clients at your agency. You would use non-probability sampling when it's not possible to do probability sampling. Working with homeless individuals or persons dealing with drugs, this would be a good approach to use. So going back to probability sampling, there's different types of probability sampling. The first one is simple random sample. Okay, so with simple random sample, each element has an equal chance of selection. So the researcher selects elements from the entire sampling frame, one at a time at random, and so that each element has a known and equal chance of being selected. So for example, if the sampling frame contains 50 elements, each element has a 1/50 or a 2% chance of being selected. So to do simple random sampling, the researcher can write the sampling units on a piece of paper and then put it in a container or a hat and shake them up and then pull out at random until they reach the desired sample size. If the sampling frame is large, however, then you may want to use like a computer program to kind of generate a list of random numbers until you reach the sample size. A more common method of simple random sampling is the random numbers table. Here's an example here of the table of random numbers. You can also find it on page 233 of your book. So with the random numbers table, you would select a random start. You would just start at some random location, and then you would proceed down to the nearest column of random numbers, and then you would read the same number of digits that is consistent with the number of digits in the desired sample size. And once you select your numbers, then you're going to match the random numbers from the table to the numbers assigned to your elements on the sampling frame. And then that's who you would select to be in the sample. The next approach is the systematic random sampling. So With this approach, the researcher computes a sampling interval based on the number needed for the sample. So for example, if the researcher has a list of 300 names and plans to have a sample of 50, then the researcher would select every sixth name, and the researcher then would select the first element using a random start within the sampling interval from between 1 to 6. And finally, beginning with the random start, the researcher selects every sixth element until they reach the end of the sampling frame. So when it comes to the systematic random sampling, the researcher decides where they want to start, right? You can be every sixth item, every ninth element, every 10th person. You decide that. Make sure that order does not bias your list. Okay, so you have to make sure, like, if when looking at it, if you select every 10th person, is that going to select participants all from one race? If you select every 10th element, is it going to select only from one gender? So stratified random sampling is used when the researcher have reason to believe that the outcome or interest varies among the different subgroups in the population, and those subgroups run the risk of being overlooked or underrepresented in a sample whenever using systematic or random sampling. And so then the researcher would select to do stratified random sampling. So for example, when researchers from an organization examine health habits among seniors, they know that the results may vary by those who are using a landline phone and those who use a cell phone. For this reason, they make certain that their samples include representatives from both subgroups. So they need to make sure that they have people in their sample that use cell phones and people who use landline phones. This helps to reduce error and by ensuring that the sample is more representative of the population than it might be if they had just used simple or systematic random sampling. So it will depend on what you're looking for or what your population looks like in terms of which is the best approach to use. So to draw a sample using the stratified random sampling, the researcher first divides the sampling frame into two or more what we call stratas to be sampled independently. The strata are categories of variables determined to be important on the basis of prior knowledge. So for example, in a study of literacy in childhood, the parents' primary language are an important variable. So the researcher in this case may decide to create three stratas: children whose parents speak only English, children whose parents speak only one non-English language, such as Spanish speakers, and children whose parents are bilingual. So sometimes the researcher may stratify the sample on more than one variable. For example, the study may further stratify the groups by language, such as Spanish and Korean, if they are primary languages, if those are primary languages of the participants. So the more variables, however, the greater the number of strata. So be careful, because the more variables that you're using, then the more stratas you're going to have to create. And the larger the sample size will be needed to do that. So if your sample is small, then you would need to do less stratas, right? But if you have if you're trying to do several stratas, then you may have to have a larger sample size. There's two different types of stratified random sampling. One is proportionate sampling and then disproportionate sampling. With proportionate sampling, the proportion of each stratum in the sample corresponds to its respective proportion in the population. So elements are picked in proportion to their number in the population. With disproportionate sampling, the size of the stratum is not the same as the proportion it constitutes in the population. So some elements are oversampled to make sure that they're increasing their representation. So basically, with disproportionate sampling, it is used when the number of elements with certain characteristics are so few in the population that we need to oversample them to make sure that we have adequate number of subgroups that we can compare to. So for example, let's say you're doing a study of students' needs and you have a sample of 100 students, if only 8 students speak English as a second language, then you'll have to include all 8 of those students in order to get a better understanding of their needs. Because if you're looking at 100 people, but only 8 people speaks English as their second language, then it is important that you get as much information, and in order to get a more adequate information, you would have to get information from all 8 of those participants. So when it comes to disproportionate sampling, it's basically meaning that sometimes we may have to oversample a specific group because the group is so small that in order for us to be able to get a representative sample, we have to sample, or we have to make sure that we're getting data from all of that group to make sure that we're able to have representation. So then we have the cluster sampling for whenever you're using large groups. So cluster sampling is the selection of elements from aggregate groups of elements. So for example, let's use individual students as sampling unit. Obviously, the national student population is immense, and so how can we randomly sample such a large population? One approach is to use multi-stage cluster sampling. With this approach, you would repeat random samples until you reach a manageable cluster of sampling units. So, for example, let's say you wanted to sample high school children in your state. So the first cluster that you would do would be by county, and then you'll have another cluster by school district, and then you'll have another cluster by schools, then by classes, and then finally by students. So you would have to randomly sample at each of those levels. So basically at the first cluster, let's say by county, so you would randomly select by county, and then from those counties that were selected, then you're going to randomly select by school districts. Then you're going to randomly select schools within those school districts that were selected. And then you're going to randomly select classes from those schools that you selected. And finally, you're going to randomly select students from each of those classes that you randomly selected. So you would have to do random sampling at each one of those levels. So it gets to be a lot, especially if you're having a lot of clusters, right? For each cluster, you have to randomly sample at that level as well. So the thing is with this approach also, you have to think about error. So you're going to have to assess possible errors because error can happen at each level. At the county level, at the school district level, the school level, the classes level, and student level. Each one of those levels will have a possibility for errors. So here's a short video demonstrating these random sampling techniques.
A sample is part of a population, and researchers use samples to collect data and information about a variable or variables from the larger population. To obtain samples that are unbiased, there are mainly 4 different sampling techniques or methods: random sampling, stratified sampling, cluster sampling, and systematic sampling. A random sample is a sample where every member of the population has an equal chance of being selected. There are a few different ways to do this. The researcher could number each member of the population. To keep it simple, say a population of 90 members. He or she could then place numbered cards 1 through 90 in a hat or bowl or mixer and select as many cards as needed to complete the sample. Or they could use a calculator or computer to generate random numbers. Or they could use a random number table like this one. A stratified sample is where a researcher will divide the population into subgroups to have members from each segment of the population, and a random sample is derived from each subgroup. For example, let's say you wanted to know how much money people saved on a yearly basis. You could have subgroups of people in their 20s, in their 30s, in their 40s, and in their 50s. You would then take a random sample for each of these groups. A cluster sample is obtained by dividing the population into sections or clusters, then randomly selecting one or more of the clusters and using all of its members as members of the sample. This is often used when the population is large or there's a large geographic area. For instance, let's say you wanted to survey small business owners in a very populated city. It would be costly and time-consuming to survey every single small business owner. So you could create a cluster sample using zip codes and maybe survey 2 or 3 of the 13 different possible zip codes. Cluster samples can be efficient and cost-effective. However, there are times when the cluster does not represent the population. A little note, the main difference between cluster sampling and stratified sampling is that subgroups in the stratified sample have similar characteristics, and the subgroups or clusters in the cluster sample are intended to vary in characteristics. A systematic sample is where a researcher will assign a counting number to every member of the population, then select a random number, then select members for the sample at regular intervals from the starting random number that was selected. For example, let's say you wanted to know how much time people living in a singles-only apartment complex spent watching Netflix on a weekly basis. You would want to get, say, a sample of 50 members. If there were 1,000 units in the complex, you could number the units 1 to 1,000 and generate a random starting number, say 234. Since you want a sample of 50, you could divide 1,000, the number of the population, by 50 to get 20, which would be your interval number. So 234 would be selected for the sample, then 254, which is 234 plus 20, then 274, which is 254 plus 20, and so on until you had your 50 members selected for your sample. This sampling method is easy to use if the population can be easily numbered. Another note, even when using the best sampling methods, a sampling error, which is the difference between the results of a sample and a population, can occur. And there is one other sampling method called a convenience sample, where a researcher develops a sample from members of the population that are easy to get or convenient. Many times these samples lead to biased results.
So here are the non-probability sampling. We have convenience sample. So with convenience sampling, this is when you select the most available elements to constitute your sample. So convenience may be based on geographic closeness, ease of access, or other opportunities such as a presence at a conference. So a lot of the times, social work research uses convenience sampling because it's relatively quick to use and it's very inexpensive. The thing with convenience sampling is that you cannot generalize it to the broader population because there's no justification to claim that the sample is really representative of the larger group, which is the population. So convenience sample is usually done because it's easy, it's quick, it's inexpensive, there's easy access. So for example, if college professors are doing a study, a convenient sample for them would be college students, right? Because it's easy to access students. And college students are a convenient sample for so many different research. The other one is purposive sample. And basically with this, there's a specific purpose as to why you're selecting specific cases. So there's a purpose in why you're including certain people in your sample. It can be things such as they're the worst cases or the best cases, or it may be because they're experts or community leaders. So those are just some reasons. You may have specific purpose why you're selecting those people. Snowball sample is whenever you have one lead and it leads you to others. So for example, this is a good one to use whenever you're working with the homeless population, because it's hard to get access to those who are homeless because you don't know where to find them, right? So basically you may get one homeless person and you can tell them about the study and you can tell them to let others know if they're homeless, if they would be interested in being a part of the study. So if you get access to a homeless person, you can always tell them about the study and tell them to pass on the information to other homeless people, and that way they can participate in the study as well. It's also a good approach to use with sex workers or gang members. Again, these are people that are hard to get access to, and so you'd have to do word of mouth, and it's easier to access them if you let someone else know and have them tell other people in the same condition or in the same situation about the study. Then there's quota sample, and this is like stratified sample, but there's no random selection. For example, you can select people at a rock concert or some people at a professional conference. So you would select people until you meet that quota. So a concert or a professional conference, you will find a lot of people there, so it's easier to meet a quota where there's a large group of people. Okay, so sample size. How do we decide how big of a sample we need? Well, that depends. It depends on several things. It depends on precision, your desired precision. It depends on the degree of variability in the population, on key variables that you're working with. It will depend on the type of sampling method that you choose. It would also depend on your plan for your data analysis, as well as how much non-response or attrition rate you expect. Whenever the sample size, whenever the sample size of the population is relatively small, the researcher may want to study the entire population rather than just a sample. Another key factor that really affects the decision on the sample size is whether the researcher has chosen to use probability or non-probability sampling. Whenever using non-probability sampling, the sample size is based on conceptual rather than statistical considerations. So when it comes to the desired precision, the question of how big a sample should be is determined to a large extent by the amount of sampling error that the researcher is willing to accept. Sampling error is the degree of difference between the sample and the population from which it was drawn. Confidence level tells us how sure we can be that the results from our sample represents the actual population. So by convention, most researchers in the social sciences use a confidence level of 95% as their standard. A confidence level of 95% means that if the same study were conducted 100 times with random samples drawn from that same population, then it would represent the true population values 95% of the times, or 95 times. So that would mean that you would only be wrong 5% of the time. The confidence interval indicates how far the sample's results can stray from the true value in the entire population. This is the plus or minus margin of error. The margin of error of a sample depends on the number of elements included in the sample. The margin of error, or the confidence interval, is calculated by dividing 1 by the square root of the number of elements in that sample. Thus, if the sample size is 50, we divide 1 by 7.1, which is the square root of 50. And this equation produces a margin of error of plus or minus 14%. So you would end up with a margin of error of plus or minus 14%. Here are some sample size tables. These tables in calculators can provide sample size needed for any given margin of error and confidence level. So you decide what that margin is and what the confidence level is that you're working with, and then looking at the table you can decide which one. So for example here, if the population size was 100 and our sample, we were looking at a plus or minus 5%, there's a plus or minus 7%, or the plus or minus 10%. So we can determine which level of precision we want, or the confidence level here. And so let's say we go with plus or minus 5%. So if our population is 100, we would need a sample size of 81 if we wanted to stay at a plus or minus 5%. If we wanted to go up higher at a plus or minus 7%, so then we can see our sample size drops to 67. And if we go higher to 10%, then our sample size drops even lower to 51%. The stronger our confidence level, the larger our sample size is. So if we want to make sure our confidence level is at 95%, then we need 81 people in our sample if our population is 100. If we want to go with a confidence level of 90%, then we would only need 51 people if our population is 100. That number changes based on your population size. So you would need to know the size of your population. So come down here to 450. If your population is 450, if you're looking at a confidence level of 95%, you would need 212 people in your sample. If you're looking at a confidence level of 90%, you would need 82 people. So again, very important that you know your population size. All right, here's also a link that you can use to find sample sizes if your population is larger. So if you have larger populations, you need larger sample sizes, then you can use this link to find exactly what that sample size should be. There's some other things that you should consider, and one of them is your population variation. So if you have homogeneous population, then you would need a smaller sample. So if people in your population, if they're very similar, they have the similar interest, the variables that you're looking at, they're similar in all of those variables, then you need a smaller sample size to be able to get accurate results. If your population is heterogeneous, meaning they're different, then you would need a larger sample size. So for example, if you're looking at a diverse city such as LA, you may need a larger sample. So another consideration is the statistical analysis that you're using. Some statistics require specific sample sizes. So some statistics, for example, may need 10 cases for each variable. So for example, if you have 3 age groups and you're also looking at their sex, which is 2 different groups, male and female, and then by their race, let's say you have 4 different groups, white, black, Hispanic, Asian, then what you have to do, you have to multiply all of those groups, which is 3 times 2 times 4, and you get 24. So if you have 24 groups, then you'll have to multiply that also by 10 cases because you need 10 cases for each variable. So then you 24 times 10 is 240. So that would mean, based on this statistical analysis here, that you would need to have at least 240 participants in your sample. The other thing to consider is attrition and non-response. So attrition and non-response is basically whenever people decide not to be in your study, or they drop out, or they just don't respond to the questions, or they may just refuse to do it. There may be some language problems, lack of availability, illnesses, anything can happen where people decide not to be in the study anymore. Attrition has to do with them being lost, so they either drop out of the study. 10% is a good number to expect to drop out or not respond to your study. And so it's always good to increase your sample size by 10% just to cover those who will drop out. And finally, feasibility. Feasibility has to do with how much time and money you have to invest in this research study. And so how much can you put into it? Diversity issues is also something to think about in terms of your sample. So not only making sure that you're including everyone, but also making sure that you have a diverse group and you're making sure that you have enough people in the sample, and then also making sure that you're engaging and keeping everyone in the study. Okay, so that brings us to the end of chapter 8 on sampling. And so hopefully with this chapter, you're able to write a draft of what your sampling plan is going to be for your final paper. If you have any questions, we can talk about it the next time we have a live chat.